Okay, now I want to talk about what kind of sort of questions you get on 13C NMR in exams. Now with 1H NMR, you get, 1H, you were given, with 1H, you are given the molecular formula, you are given the spectra, and you have to work out the structure. Now with 13C, as we've seen, you don't get as much information, so they don't ask you to do questions like that. A typical 13C question, when they've asked this several times, is, right, let's think we've got these isomers, so this is a benzene ring, and if you don't know what a benzene ring is, you can think of it as it's 6 carbons, skeletal form, right, alternate single double bonds. So that means each carbon has got a hydrogen attached to it. So it's going to be C6H6. That's a benzene ring. And it's sometimes drawn like that instead. Okay, so we've got a benzene ring, and you can have, let's say you've got myself a bit of room. You've got an ethyl group attached to it, okay? So that would be ethyl benzene. Okay, another isomer of that would be a benzene ring. Instead of having an ethyl, you could have 2 methyls. It'd be 1,2-dimethyl benzene. Or you could have 1,3-dimethyl benzene. Or the final one you could have is 1,4-dimethyl. Obviously, if you put it on this carbon here, it would be the same as having it on carbon atom number 3. So that's not a possibility. Right, so the question was, see how many, it would say, right, how many peaks in each of those compounds? 13C spectrum. So let's look at this first one, right? So this carbon here is clearly different to any of the others, so that's 1. And this one here is different to the others, that's 2. This one here, that's different. But then if you look at that one, which I'll do in blue, well, that's exactly the same as this one here. That's the same, isn't it? And that one in green, well, that one's the same there because you've got symmetry. And finally, you've got this one here, which is different as well. So that would give you a total of 1, 2, 3, 4, 5, 6. You get 6 peaks in the spectrum. Let's think about this one. So these 2 methyl groups, these 2 methyl carbons are the same as each other, and as are these 2 here, they're the same. There's a lot of symmetry going on here, so that blue one is the same as that blue one there, and then these 2 greens are the same as each other. So that's going to give us 1, 2, 3, 4 peaks. So you can pause the video and do the last 2 yourself, and then start again, see if you get the right answer. This one, okay, the methyls are the same. This one is unique, isn't it? But that blue one there is the same as that one there. That one, any the same as that? Yeah, that one there's the same. And finally, this one is different. So it's 1, 2, 3, 4, 5 peaks for that one. This one, now you can see there's a lot of symmetry going on here, isn't there? So those 2 methyls are the same as each other. That blue one there is the same as that one there. Now let's think about this green one. Well, it's obviously the same as that one, but not only that, it's the same as that one and that one. So that's just going to give us 3 different peaks. So as I say, that is a typical question on 13C. They don't tend to be big, long 7-8 markers like you get with the 1H NMRs. It tends to be just 1 or 2 marks. What I have, this is the most difficult question they've ever asked on 13C NMR, and it is, I'll show you in a minute. I mean, you can see from this one, you don't actually have to look at the ppm values or anything. It's really just literally how many different carbon environments are. But on one question a few years ago, they did actually ask that. So I'll get it up here. I think it was 2015 on the old module 4. If you want to look at it on if you want to look at the old paper. Okay, so what have we got here then? We've got the spectra, 2 different spectra here. And then there are 5 compounds, P, Q, R, S, and T, and it said you have to basically say which which of those compounds corresponds to the spectra. Okay, so the first thing to do would be to count. The most logical thing to do would be to count the number of peaks each of those is going to give you, to see if that gives us a way in. Okay, so let's look at this spectra first of all. We have got 1, 2, 3, 4, 5, 6 peaks with this one. So we've got 6 environments for this one here, and here we've got 1, 2, 3, 4, 5, 6 with that one. So this is not this. We're not going to be able to just distinguish them from the number of peaks. Right, let's see how many if we look at these compounds. Okay, let's see how many peaks this would give us. So P, and again you can pause the video if you like. How many peaks do you think you're going to get there? Well, that's 1, 2, 3, 4, 5, 6 peaks there, isn't it? So that's not going to help us really. Q, have we got 6 peaks there as well? We have each of those carbons is unique. They're all different, so that will give us 6 peaks. Same with R. Yeah, those carbons are all unique, so that will give us 6 peaks as well. These are a bit more tricky, aren't they? That's 1. That's unique. 2. These 2 are different to each other. Yeah, that's going to give us 6 peaks, and T will also give us 6 peaks. So you can't just do it by looking at the number of peaks. That's not going to work. So we are going to have to look at the ppm values there. Okay, so let's see. Not necessarily saying this is going to be the quickest one, but let's just look. 2 of those compounds have got carbonyls. P and Q have got carbonyl carbons in them. Yeah. And if we look at our ppm there, the carbonyl carbon should give us a ppm of at least 160. And neither of these 2 spectrums have got anything after 160. So I think we can safely say that we are not dealing with P and Q. So we'll cross those out. Let's have a look at these. Now, I think what strikes me about spectrum 2 is we've got these 2 peaks here, which are around about, they're very similar to each other, but they're like about 120, 130. So let's look at the ppm scale. Have we got anything there? What I would say is that is a likely, right, this is very likely, isn't it? Okay. They're in the right range. So the only molecule with a carbon-carbon double bond in is R. So I think that is R, because those 2 would first of all, that carbon and that carbon, they're going to be pretty similar to each other, but not exactly the same. And they're going to be in the range 90 to 150, and they're 130. So I think that one is that. Okay, so now we've got to use figure 3. We've got to somehow be able to tell, is it S or is it T? Again, I think let's have a look at these two peaks here, which are pretty similar, and they are at about 70. Have we got anything there? Well, yeah, we have. We have got alcohols, ethers, or esters. They should be about right now. An ether, by the way, just remind what an ether is, because we don't really do anything about the chemistry, but they come up in questions NMR. An ether is when you have an oxygen like that between two carbons. So that would be the simplest ether. That would be dimethyl ether. Have we got either of these got an ether in it yet? T has got an ether. Okay, let's have a look at T. It's got an ether. So, and he's got that carbon there and that carbon there, which are part of the ether group. So yeah, that could be these two peaks here, and I think that's right. I think that's what's going on there. Just to double check, let's have a look at what's going on with S. Let's look at S now. S has got it's got this carbon here, which is probably more which is a bit different to the others, isn't it? That's a carbon attached to an OH. Again, that should give us about 50 to 90. Okay, but yeah, we've got in figure 3, we've got 50 to 90. We've got those two, but there's 2 peaks there, and this compound would only give us 1 in that range. So I don't think it could be S, and that's what makes me think it was T. As I say, that is the hardest 13C question they've ever asked, and it's the only one where you've ever really had to look at this table. Most of the time you don't really need to look at the table. It's just a matter of counting number of peaks. Okay, so 13C, not as much to it really as for us anyway, as there is for 1H.